Now, we're going to talk about something that the book doesn't really derive. And it's an interesting topic, so we're going to talk about it briefly, but it doesn't have that many places that it comes in. And this is the idea that we actually get momentum transfer from electromagnetic waves. So from Maxwell's theory, which again we're not fully deriving, we can have a change in momentum being equal to the energy absorbed by an object divided by c. So this is basically the electromagnetic energy absorbed divided by c gives you a momentum change. So we can then go back to force, and this takes us back to the first half of intro, and a change in momentum, or an impulse, is equal to force times time. So if you want to think about this as an average force, that would be the change in momentum divided by time. And we said that change in momentum was energy absorbed over c, so we now just have a change in time hanging out. But energy absorbed over time is equal to power, and so now we have a force is equal to power over c. So this is just playing with a bunch of different equations. So the interesting conclusion from this is that there's something called radiation pressure. And a pressure is a force divided by an area. So our force was power over c, but now we have divided by area, and power divided by area was our intensity. So the takeaway is that our radiation pressure is equal to intensity divided by c. So this basically says that if you have light shining on a surface, that light is actually exerting a pressure on the surface. So again, that's a force divided by an area. And so we can relate that back to intensity, and there's a square, a spare factor of c hanging around. So why do we care? Well, one of the cool applications of this is the idea of solar sails. That if we had a vehicle that we were launching into space, and we had some basically giant sheets of tinfoil, that the electromagnetic radiation from the sun would actually exert a force on this, and that could actually provide propulsion. So solar sails are a cool application of radiation pressure, and there are some other ways that people have thought about using radiation pressure in different environments, but it is just an interesting thing to think about. Now, all waves actually transfer energy. For instance, sound waves do as well, but when we're talking about electromagnetic waves, it's interesting because it's the electric and magnetic fields, self-sustaining as a propagating wave, that transfers this energy.